Hello friends, and welcome to Commercial Mathematics 2. Under this Commercial Mathematics 2, we'll be looking at ratios, then variations of proportionality. Okay, under variations of proportionality, we'll be looking at direct variation, inverse variation, joint variation, and partial variation. And please do not forget the links below the video where you can find exercises under these topics. Now, these are video exercises, and believe me, these are life-changing exercises. These are exercises that will boost you under these topics here. Now, we also have questions or exercises from our past questions. We have from JAMB past question, we have WAEC, GC, we have POST UTME. And we also have the link for 500 boosters, your problem solving in mathematics. Remember, 500 boosters, it is a summary of what mathematics is all about. It is a quick handbook on mathematics that it contains every topic you can think of in mathematics. So let's start. So ratio. What is ratio? Ratio can be defined or can be termed to that mathematical expression that indicates the relationship in size between two or more commodities or quantities. So what does that mean invariably? It means that if you want to show the relationship between two or more items or quantities in size, then we do it using ratio. For example, if I have let's say 20 shoes and 50 shirts. Okay? Now if I want to show the relationship between the number of shoes that I have to the number of shirts I have, I will represent it using 20 is to 50. Alright? Now if I want to show the relationship between the number of shirts I have to the number of shoes I have, now it is the ratio of the number of my shirts to the number of shoes I have. So it will be 15 is to 20. Okay? So invariably, ratio, it is that mathematical expression used to denote or to indicate or to show the relationship in size or in quantity between two or more commodities. Now, and just like what we have on the board now, this is how we represent ratio. Now, ratio is being represented using a column. Okay? Now, we can represent three items. For example, if I have a bag that contains 5 oranges, 10 mangoes, and 3 guavas. So I can show their relationship. Now I say we have 5 mangoes, right? 3 oranges. And then 2, let's say apples. Okay? Now these are the fruits I have in my bag. Now, if I want to show the relationship in size between these fruits, now how do I indicate it or how do I show it? Now, I show it using ratio, and that will come in this form. Now, that is 5 mangoes is to 3 oranges is to 2 apples. Okay, so this is how I show the ratio of the number of the number to different fruits that I have in my bag. Okay. Now let's try to explain what this ratio simply means. Now, if you look at this, okay, in ratio questions, this ratio is used to show a standard unit. And what do I mean by standard unit? Or it is used to show a standard procedure. Now, this means that for every set of fruits that I have, okay, that I should have 5 mangoes, 3 oranges, and 2 apples. So now 5 plus 3 plus 2 give us 10, right? So it means that for every 10 fruits, or 10 fruits that I have, now it should contain 5 mangoes, 3 oranges, and 2 apples. Now ratio, fraction, relationship. Now what is the relationship between my ratio and my fractions? Now this relationship can only be related to the ratio between just two different quantities. Okay, so if I have 2 quantities, let's say 5 is to 3. Okay, now and I want to relate this in fractional form. Now I can represent this in fractional form by writing it as 5 all over 3. Alright, and if I have 2 is to 1, I can relate this in fractional form as 2 all over 1. So this is how we can relate our ratios and fractions. So this means I can convert from ratio to fraction, and I can convert from fraction back to ratio. Up next will be basic ratio. Now, what is a basic ratio? Now, a basic ratio can be termed to be the smallest unit of a ratio. And what do I mean by that? For example, if I have a ratio of 10 is to 45. Alright? Now, this is 10, this is 5. Now, if I should compare these two numbers, I'll find out that they possess a common factor, which means that they can still be broken down further. So, if I should divide this by 5, I'll have 2. And if I should divide this by 5, I'll have 9. Now, look at 2, look at 9. There is no factor common to the two of them. So 2 is to 9 can be termed to be the basic ratio of 10 is to 5. Now, also, if we have something like 5 is to 20. Now, if you look at 5 and 20, they possess a common factor, which is 5. So if I should divide 3 by 5, I'll have 1 is to 4. Okay, now this is the smallest unit of this very particular ratio. So a basic ratio can be termed to be the smallest unit of any particular ratio. Now, basically in mathematics, now our basic ratio is the most acceptable form of representing our ratios. So let's look at one or two examples on that ratio. Alright, let's look at our first example on that ratio. We have that Phil, Joe and Fred shared 45 packs of sweets in the ratio of 4 is to 3 is to 2 respectively. Find the number of packs of sweets gotten by each person. Okay? Now this respectively means that the ratio comes as the pattern of the ratio is in the pattern of the appearance of the names, which means that 4 is for Phil, 3 is for Joe, 2 is for Fred. Okay? So what does this 4 is to 3 is to 2 mean? Now this means that for every set of pickings, now each time that Phil is entitled to 4 packs of sweets, Joe is entitled to 3 sets of packs of sweets, and Fred is entitled to 2 packs of sweets. So for each time they pick, Phil picks 4, Joe picks 3, and Fred picks 2. Okay? So we have that. Let's write our solution. So we have that the total number of packs that share in total sweets is 45 packs. Alright? So we have that Phil is entitled to 4 packs, then Joe is entitled to 3 packs, and Fred is entitled to 2 packs. Okay? Now let's go this way. Now 4 is to 3 is to 2. Okay? Now for each set he picks 4, each set he picks 3, and each set he picks 2. So which means that for every single set we'll have a total number of 4 plus 7 plus 2, which is equal to our total ratio to be 4 plus 3 plus 2, which is equal to 9. Okay? So it means that for every set that they pick, now we have 9 sweets gone. Alright? Now, so we'll determine how many sets that can be found in 45. Remember, in each set, they remove 9 sweets. Okay? So we'll determine how many 9 sweets that can be found in 45 packs. So we'll have that for one set, we have 9 packs removed. Therefore, in how many sets will the 45 total number of packs be consumed? So we'll come and multiply to have 4, 5 times 140 by 9, which is equal to 5. Okay? So this means that before these 45 packs of sweets can be consumed, they will have to go for 5 different sets. And we know that in each set, Phil will always pick 4. In each set, Joe will always pick 3. And in each set, Fred will always pick 2. So we have that if for Phil, okay, now if for every set he picks 4 packs, then if in one set he picks 4 packs, in 5 sets he should have 4 times 5, which is equal to 20 packs. Okay, now then Joe, If in every set he picks 3 parts, it means that in 5 sets he should have 3 times 5, which is equal to 15 parts. Then, and for Fred, if for every set he picks 2 parts, it means that in 5 sets, in five sets, okay, he should have 2 times 5, which is equal to 10 parts. Okay, which means that after they must have shared these 45 parts, now Phil should have 20 parts, Joe should have 15 parts, and Fred should have 10 parts. And if you should sum 20 and 15 and 10, you still get back the total number of 45 parts they share. Okay? Now basically, that is what ratio is all about. Now, but if you don't want to take this rigorous process, I did this so that I can explain the principle of ratio to you. But if you don't want to take this rigorous process, okay, now we work with what we refer to as, our total ratio. Now, our total ratio is 9, right? Which means that Phil, the fraction that Phil possesses will be 4 out of 9. Okay, remember in each set we have 9, right? So Phil for every set, his fraction for every set will be 4 over 9. And the fraction for Joe will be 3 all over 9. And the fraction for Fred will be 2 all over 9. Okay? So we can easily find Phil's share by saying his fraction times the total number of parts that they are sharing. So we'll have Phil to be equal to 4 over 9 times 45. To have this to give us 20 parts. And we'll have Joe's. Now Joe's fraction is 3 out of 9 times 45, which will give us 15 parts. Okay? And we'll have Fred's. Now his fraction is 2 all over 9. Now times 45 over 1. So we'll have 10 parts. Okay? So you can either go through this process or you go through this process. Now they basically should give you the same answer. So that is basically it on the principle or on what we. Now let's for us put the variations.